All right, here's a couple of questions dealing with concentrations of solutions. So this one says I have two solutions, sodium chloride. So I've got one solution that's 2 molar, and I've got another solution, one that says I have way more of it, 5 molar. And then they say you add the solutions together. So you put these things together into a bigger container. So you probably have this much of the 5 molar, maybe that much of the 2 molar. I'm just sort of guessing. Then they say which of the following could be the concentration. Well, it can't go higher because like if this concentration is 5 and this one is 2, you don't add the concentrations. What would it be like? I guess if you have Kool-Aid, Kool-Aid that you mix up really strong, and then you mix up some Kool-Aid, same package, but you mix a whole bunch more of it. And then if you put the two together, you can't get one that's more concentrated than this one. So if this is really purple, I can do colors. So if I have this one, that's not purple, but it's red, and then maybe let me try one that's like this, so not as red. When you put them together, you're going to get something that maybe looks like this, sort of in between. Does that make sense? Hopefully. So that's what's going to happen with these solutions up here, is when you put them together, the concentration has to be somewhere in the middle. So if they were exactly the same size, this was 2 and this was 5, if I had the same amount of each, then I would just average those. So I think you'd come up with like 2 or 3.5 would be your molarity. But if they say you have way more of this, then your concentration is going to be way slanted toward the 5. That's why it's probably around 4.6. So it can't be these ones because they're too high. So, and 3.5 would be if they had equal amounts of each one. This one would happen if the 2 was big and the 5 was real small. Okay, so this one, so you've got 5 molar and you just dilute it a little bit. And so its concentration goes down just a bit. Okay, next question. It says calculate the concentration of chloride ions when you got a mil of sodium chloride and mixed with 250 mils of that of calcium chloride. Oh, so I have two solutions. Let's do sodium chloride first. So sodium chloride, when you put it in water, it dissociates to sodium ions and chloride ions. Okay, so they say the concentration is 0.231 and I have 100 mils of that. So if I look at my formulas, C is equal to N over V. I know concentration, I know volume, so I could figure out moles. And that's what I really want to do, is I want to figure out the moles of the sodium chloride, moles of the calcium chloride, and then figure out the moles of their ions, which I can do with this ratio, the 1 to 1 to 1 and whatever the other one is. So figure out the total moles and then divide it by whatever the total volume is. So let me do that. So moles of sodium chloride are the concentration, 0.231 moles per liter, times by the volume, 0.100 liters. Liters cancel, so the moles would be 0.0231 moles. So that's how many moles of sodium chloride have. Since that's these ratios 1 to 1 to 1, that also tells me that that's how many moles of the chloride ions I have. Now let's do the same thing with the calcium chloride. So calcium chloride, there's our formula, yields calcium ions and 2 chloride ions. So now the ratio is 1 to 1 to 2. So let's figure out the or not the concentration, but the moles of this. Again, C equals N over V, so N is equal to C times V. The concentration of the calcium chloride is 0.150 moles per liter times the volume, 0.250 liters. Okay, I have to calculate that. 375, I'm betting. 0.15 times 0.25. Yeah, 0.0375. 0.0375 moles. So that's how many moles of this I have. 0.0375. Also, that'll be how many moles of calcium ions I have, but it's going to be double, so I'm going to have to times this by 2. I think that's 0.0750. Let me just figure that, times 2. Yep. So this is how many moles of chloride ions I have. And then I can say, well, I have that many moles of chloride ions that came from the sodium chloride. So the moles total that I have is going to be 0.0231 moles from the sodium chloride plus 0.0375 moles from the calcium chloride, or from the ions that I got from the calcium chloride. So if I total all those up, that would be 0.06 maybe. 6, 10, 1. Yeah, there. 0.0606 moles of chloride ions. Now if I want to know the concentration, so the concentration of chloride ions, that's concentration, is equal to moles divide volume. Moles 0.0606 moles divided by the total volume. 100 plus 250 would be 350 mils, or 0.350 liters. So my concentration is going to be moles per liter. Now I just have to figure out what that comes out to. Okay, calculator. 0.0606 divide 0.350. There we go. 0.17314.286 molar. I don't see that answer. Did I do something wrong? I'll go back and look here. Maybe I added something wrong. I need to do sig figs. I've got 4, 3, 4, 3, so I need 3 sig figs. So it'll be 0.173 moles per liter. Now let's see if I did anything wrong. They say the correct answer is 0.280. Okay, I like this part of the game just to make sure I can go back and identify anywhere where I might have made a mistake. So moles is equal to concentration times volume. So 0.231 times 100, 0.100. So that's got to be 0.0231. Maybe I was wrong. 0.231 times 0.1. I'm right. Okay, and then calcium chloride. Same thing. So 0.15 mole per liter times 0.25. You get 0.0375. Maybe there's not a 0 in there. 0.15 times 0.25. There's a 0 there. Plus 231. 0.0606 divided by the total volume, 0.350. No, I should get the same answer. Okay. I don't see how they get their answer. I had to pause and go back. You probably noticed my mistake. So the moles of chloride ions from salt, sodium chloride is this, that's correct. But the moles of calcium chloride, or the chloride ions from calcium chloride, is that, not that. That's why. So 0.0750. So let's add those together. 0.0231 plus 0.0750 equals, so the total moles from both solutions is that, and it's funny because I even made a point of saying that that's how many moles you get from there, but then I just took this number. Okay, then I take this number and divide it by 0.350. There it comes out. So this number's not right. It's 0.0981 moles. And then when you divide, you get 0.28571 moles per liter. But they want 3 sig figs, so 0.280 molar. Yeah, they were right. All right, hopefully that helps you with those two questions.